Welcome to qnawire.
A solid uniform 45-kilogram ball of diameter 32 centimeters is supported against a vertical frictionless wall by a thin 30-centimeter wire of negligible mass. Draw a free body diagram of the ball and use the diagram to find the tension in the wire. Okay, so starting with our free body diagram. We have the object. We have the weight, so mass times the acceleration due to gravity. We have the tension pulling up and to the right. The normal force is always perpendicular to the surface and it's against a wall. So the tension has an x component, let's call this theta, and the tension has a, whoops, this is the y component, that's the x component, that's theta. Okay, so let's write our givens. The mass is 45 kilograms. The diameter of the ball in meters is 0.32 meters. That means the radius is 0.16 meters. The length of the wire is 0.3 meters. So we have the ball. This is the radius. It's going up, so this is 0.3 meters. This is the radius, and it's going to make a right triangle. So this piece here is what the 0.3 meters is. And then this piece is also R. So we know that sine of theta is opposite over the hypotenuse. So the opposite is the radius, so 0.16. The hypotenuse is 0.16 plus 0.3. This gives us an angle of 20.35 degrees. So once we have the angle, we can find the force. So we know the normal force is equal to the tension in the x direction by Newton's second law. The weight is equal to the tension in the y direction. So the tension in the y direction is the tension times cosine of theta. So the tension is mg over cosine of theta. So solving for the tension, and we get 470 newtons. Part B, how hard does the ball push against the wall? So we need to find the normal force. So since we know T, we know the tension in the x direction is T sine of theta, and that is equal to the normal force, and therefore we get a normal force of 163 newtons.